The fuel pressure regulator, or more commonly known as the suction control valve, plays a vital role in diesel engines. If a P0089 was to set, what should we check for? And what are the steps required to resolve the problem? G'day, I'm Zach. Welcome to Automate. Put simply, this valve works in a closed loop system with the fuel rail pressure sensor, ECM and injectors. There are several different common rail pumps used by OEMs. Some may use multiple suction control valves to adjust fuel delivery for each pumping chamber, but their operation is still the same. The suction control valve relies on feedback from the rail pressure sensor in order to supply the correct amount of fuel, keeping the rail at its working pressure. The suction control valve regulates the amount of fuel entering the pumping chambers to meet all engine load conditions. The valve receives a duty cycle control from the ECM in order to allow more or less fuel into the pumping chambers. The ECM monitors the fuel rail pressure sensor to determine if the commanded and actual pressure are within a predetermined range. If they fall outside the desired parameters for a predetermined time, a P0089 signal performance or high fuel pressure code may set. This may even render the vehicle into a reduced power mode. It's not uncommon for other fuel-related pressure codes to set, such as fuel rail pressure low and fuel rail pressure high. It all depends on how the OEM has written the code and what the symptom byte is. It's easy to look at the code and miss the small details, but this piece of information can help steer you in the right direction. It's important to check the failure records first, as this can save time and paint a more complete picture before you start your diagnosis. There are a variety of checks for this concern, so take your time and document your findings. Also, don't forget to consult with the customer by asking questions like, did the fault occur while driving on the motorway? Or was it during city stop-start traffic? Was the vehicle's fuel tank just refilled? Or was it experienced when towing a load? One of the first checks that must be carried out is a fuel sample. Too many times we get caught out due to bad fuel. Water entry can easily cause rust in the fuel lines and can even cause severe internal damage to the accumulator and other high pressure components. Check for any fuel supply issues. Are there any collapsed, blocked, twisted or damaged fuel lines that could impede fuel return? An in-tank lift pump supplying too much pressure can affect the correct working operation of the suction control valve. This is why it's a good idea to check the low side fuel pressure first. Connect the fuel pressure gauge between the high pressure pump and the low pressure delivery line. Turn the ignition on and inspect the gauge. On this vehicle, there should be between 60 to 80 psi. Anything above or below the specified value would need to be addressed before continuing diagnosis. Always check with the OEM specification for the correct fuel pressure value. Inspect the suction control valve connector and ensure it's installed correctly, free from dirt, water, corrosion, or even any diesel fuel that may have leaked through the control valve. While we're checking the connector, it's a good idea to inspect the terminals for correct terminal tension. A loose connection can easily encourage excess circuit resistance. With our visual checks out of the way and no faults found, it's time to check out the data and look at a wiring schematic. With a scan tool, navigate to ECM and look at the live data. Check the actual and desired fuel rail pressure. If the actual pressure is well above the desired, we would need to look at a possible fault within the suction control valve. But before we remove and inspect it, we need to make sure the valve is receiving the correct ECM controls. As always, before we commence any electrical testing, don't forget to connect a battery maintainer for stable voltage readings. Looking at this schematic, we can see that this circuit is controlled by a low side driver within the ECM, and supply current is via the powertrain relay. Using an oscilloscope, back probe the control circuit to determine the correct duty cycle at the suction control valve. Using a scan tool, operate the valve open and then close. We should see the duty cycle change as commanded. If this is seen, the control circuit is operating as designed, so the fault must reside within the suction control valve. However, if this wasn't seen, then further diagnosis of the control and supply circuit will be required. But this will be associated with other fault codes. Before we remove the suction control valve, we need to make sure we depressurise the fuel system in accordance with the manufacturer guidelines. Once removed, inspect for any abrasive scoring on the valve or bore of the pump. It's not uncommon to see some higher mileage pumps with this wear. These types of systems may seem difficult to diagnose and repair, but if you understand the DTC, read the data and validate the concern, this will ensure an accurate and efficient diagnosis. Thanks for watching. Bye for now.